We're now going to look at an implied problem. Oh, it shouldn't be all that scary. But here's the question. We're going to find a force using the projection concept. A bale of hay in a wagon with total weight 100 pounds sits on a ramp inclined at 30 degrees from the horizontal. I wouldn't try this at home, by the way. What is the force required to keep it from rolling down the ramp? In other words, what's the force on the brake, whatever the brake may be? And so we have to think about this vector representing the direction for the 30-degree angle on the ramp. And of course, that vector is just this unit vector. 30 degrees, so cosine of 30 square root of 3 over 2. Sine of 30 degrees is 1/2, so this is our vector of choice. Okay, we want to know how much of this force, which is negative 100J, because that's going straight down, right? We want to know how much of that force is in this direction. Okay, so there, how much of this force is in this direction? So we would say, well, the projection of F onto V is F dot V. All right, well, let's dot F with V. This dot with this, my arithmetic comes out correctly, I would say negative 50. So over the length of V squared, well, this is a unit vector, so duh. Squared, you still get 1. So F dot V is negative 50 times vector V. Well, here's vector V. We want negative 50 times this. That would give us negative 25 square roots of 3i plus negative 25j. So that's what we do wind up with. That's the force of the bale to roll down the ramp. Of course, that's the force that the bale is creating. And so the force that the brake you would need to stop it would be its opposite, which is 25 square roots of 3i plus 25 square roots, or 25j. No, I'm wrong. The force of the bale to roll down the ramp is negative 23 square roots of 3i minus 25j, but we want the opposite force, which is 25 square roots of 3i plus 25j, but we need to know its magnitude. When you see what's the force on the brake, we don't want that as a vector, we want what's the total force on the brake. And so the magnitude of this vector, actually the magnitude of this vector and the one in the opposite direction, are the magnitudes are the same. So we could just use this one to find that magnitude, but that's not. So that means magnitude would be 25 square roots of 3 squared. That would be 25 squared times 3 plus 25 squared times 1. That's 25 squared times 4, which is 25 squared times 2 squared, which is the square root of 50 squared, which is 50. So it takes 50 pounds force to hold this back when it's on a 30-degree incline.